All right, this is going on page 56 when we're done. And we're going to talk about composition of functions. So really today is just a giant review of Algebra 2. Function notate, well, the first thing we're doing is really a review of Algebra 1, but some of us still struggle with the function notation, so won't kill us to do that. But if we have the function f of x equals 2x minus 3, and we want to evaluate the following. I have f of 5. So since x got replaced with 5, I replace every x I see with a 5. So that will give me 2 times 5 minus 3. That gives me 7. So f of 5 equals 7. Right? Yes, it is that easy, if that's what you're wondering. It's not a trick, it's just a review. You're not always going to evaluate a number. Sometimes you might evaluate another expression, like so. So this becomes, I take that and replace every x. So I get 2 times 5x minus 1, and then the minus 3. Then I got to make sure I distribute correctly and get that f of 5x minus 1 is equal to 10x minus 2 minus 3, which is 10x minus 5. Okay. Any questions at all? All right. So when you first learn function notation, I don't know if y'all were ever introduced to a function machine, but I want you to think, you should think about functions as little machines. You got an input. So my input is x. It goes into this little machine. Whatever g is happens to it. So then your output comes out, and your output is g of x. Okay. Input, output, x, y, or x, g of x, talking about it in function notation. Right? That makes sense? Okie dokie. So when we talk about composition of functions, if you're going to compose something, you're putting something together. So a composite function, sometimes in math, we input a value of x into a function, then use the output and plug into another one. If the output of the first function becomes the input for the second function, when that happens, that is a composition of functions. And we need to be able to understand what the notation means, be able to read stuff like that without our brains turning to jello, because it's not that complicated. We've got a g of x is defined for us. Then it says let g of 2 equal c, and we want to find g of c. Okay. Well, if I need to find g of c, I need to know what c is. And I know what c is. C is g of 2. So I'm going to start by finding g of 2. That's going to be 3 times 2 plus 1. So that'll be 7, right? None of the computations you have to do are going to be crazy difficult, because we're not trying to figure out if you can add, subtract, multiply, and divide. It's just, do you understand how all this stuff works together? All right, so if g of 2 equals 7 and g of 2 equals c, then all that equals c, right? G of 2 equals 7, which equals c. So then when I want to find g of c, I'm really looking for g of what? 7. So that means that 3 times 7 plus 1 gives me 22. So g of c equals 22. Okay. Everybody okay with that? Easy enough? All right, so then we have notation. So we just kind of did it, but wasn't really notated like you usually have composition of functions notated. You can read it like, or you can see it like this, which is just me. It's just f of g of x. That's how you read it. Or what kind of looks like fog, but that's not an O, and it's not a dot. It's a tiny open circle, because a dot would mean multiplication. That's not what we're doing. I would suggest that we rewrite that as f of g of x, because it means the same thing. And I think that that makes more sense overall, because it's obvious what's going inside of the other. But an important note is that in general, compositions are not commutative, which means you can't go the opposite way, right? So generally, f of g of x does not equal g of f of x. Is it possible? Sure. You could have two functions where that happens, but just because it happens once doesn't mean it happens every time, and it's absolutely not going to happen every time. So let's go back to our function machine. And here we've got the fog, or the f of g of x, all right? And this is kind of hard to see what's inside, so that's basically what's inside of this. You take the big box out. We have our input. It goes in here. G happens. Our output is g of x. Then that becomes the input for the next one. F happens. Then your output is, well, actually, that one is, yeah. So this is f of g of x. Because the output became the input. That's all that's happening there. Okay, that makes sense to you? And remember, it's not commutative. So here's an Oreo example. You got f of x is your cookies. The g of x is the filling. F, the fog, or the f of g of x, is what a normal Oreo would look like. If you did it the other way, g of f of x, then it would be an inside-out Oreo, totally not the same thing, right? You see the difference there? Okay. Take that as a yes. All right, so back over here then. We're going to evaluate the compositions of functions. So when working with composite functions, we first evaluate the inner or the right function. Then we use the output to fill in the middle part, right? So we have f and g that are both defined. We have f of g of 3. So the first thing we're going to find is g of 3. So that's going to be 2 times 3 plus 1. That's 7. Then I'm going to find f of g of 3, which means I want f of 7. Right? That will give me 3 times 7 minus 5. It's 3 times 7. 21. And 21 minus 5 is 16. So that means that f of g of 3 is 16. Okay. Everybody good with that? All right, so here, this is the opposite. This is g of f of 3. So I'm going to start with f of 3. That is 3 times 3 minus 5. 9 minus 5, that's 4. Then I'm going to do g of f of 3, which means I want g of 4. That's going to give me 2 times 4 plus 1, which is 9. So g of f of 3 equals 9. So if you didn't believe me with the Oreo cookies, you can see that doing it the other way, you don't get the exact same numbers. Again, it is totally possible that it may happen depending on the function, but not a given for sure. Okay. Any questions at all? Okay, so then we're going to find f of 2. I'm going to rewrite that as f of 2. Okay, sometimes you substitute it back into the same function. That's a possibility. So we're going to start with f of 2. It gives me 3 times 2 minus 5, which is 1. Then I want f of 2, which is f of 1. And that will give me 3 times 1, oops, minus 5, which is negative 2. So f of 2 equals negative 2. Okay. So hopefully we're just knocking some cobwebs off of Algebra 2 stuff. This absolutely shouldn't be like new and surprising information. But any questions at all? Everybody okay with where all the numbers are coming from? Okay. For sure. All righty. So then, when we're working with compositions, the input does not necessarily need to be a numeric value. We're going to use the same functions we just used, so let's rewrite them. F of x equals 3x minus 5, and g of x equals 2x plus 1. All right. So here I'm going to take g of x, that expression over there, and substitute it into f of x here. It's going to give me 3 times 2x plus 1, and then don't forget the minus 5. So that gives us 6x plus 3 minus 5. So f of g of x is 6x minus 2. Any questions about that? All right, then y'all do B. I'd rewrite it as g of f of x first. All right. 6x minus 9. You okay with that? Any questions at all? All right. So this next part says the functions h, k, p, and m are given below, but that's a lie because there's no p, but it's okay because we don't need it. And then we're just going to do a few more examples here. So k of h of 4. So we're going to start with h of 4, right? So h of 4 is 2 times 4 minus 3. So that's 8 minus 3, which is 5. Right? Then I want k of h of 4, which is k of 5. So that'll give me 5 squared plus 4 times 5 plus 5. That's 25 plus 20 plus 5. So k of h of 4 equals 50. Okay. Any questions at all? All right. Okay, so then I want you to do B. I would suggest first rewriting it as h of m of negative 2. I got negative 11. Do you agree with that? Any questions at all about anything? All right. So once again over here, we have something that is not a we're not evaluating a number. So this is going to be k of m of x, which means I'm taking this expression and substituting it in everywhere I see an x here. So this is going to be 3x plus 2 squared plus 4 times 3x plus 2 plus 5. Then we have to correctly use our algebra skills to be able to simplify this. Now, this first thing that we square here, does this become 9x squared plus 4? It's what? Yeah, exactly. You just do them next to each other, right? So that is not 9x squared plus 4. You do not get to distribute that squared sign. That ends you up in math jail, which really should be math prison, because that is an egregious error that we cannot afford to do anymore. There is a pattern to it because it is a perfect square trinomial. It was shown to you at some point, but most of the time, most of us don't remember what those patterns are, and that's totally fine because, just as she just said, we can totally just write this out as 3x plus 2 times 3x plus 2, and then you FOIL, or you box, or you distribute, or I don't care how you do it. However you learned it, whatever makes sense to you, as long as you're not making up math, it's fine. You just got to get it done correctly. Okay, so go ahead and multiply those together, or whatever it is, however it is you're going to do it. So when you multiply these two, what do we actually get? 9x squared plus what? 12x plus 4. I'm going to punch you in the face. Plus 4. How many times did I literally just say it is not 9x squared plus 4? Oh my God. Okay. Made me threaten you on video. All right, are we good? Does that make sense? Okay. So then here, this is 9x squared. Now, I'll explain to you what the pattern is if you're a pattern person where you're like, you know what, maybe I would remember if somebody told me again. Notice I do actually have a 9x squared and a 4, but there's something else in there. So I've got this plus 4 here. Well, the way we get this plus 12x is you multiply these two together and then you double them. So 2 times 3x is 6x. You double that. That's where that 12x is coming from. But it also comes from FOIL or whatever else you're doing. So I think sometimes it's safer just to do this than to try to remember a pattern. Then we have to distribute correctly. Plus 12x plus 8 plus 5. So that k of m of x equals 9x squared plus 24x plus 17. What questions do you have? Anything? Algebra, algebra, algebra. We have to be good at those things. We cannot keep making the same mistakes over and over again. All right, any questions? Okie dokie. Next example here. So it says that the figure shows the graph of f on its domain from 0 to 9. The function g is given by this right here. You got to make sure you have them identified correctly and that you're using them in the right order. Then they have also defined h for us. H is g of f of x, no matter how you write it. And we want to find h of 6. So h of 6 is g of f of 6, right? So how do I figure out what f of 6 is? Where would I go to look for that? The graph. So when x is 6, my input is 6. What is my output? 1. So f of 6 is 1. So that means this is equal to g of 1. Then I use the g function right here and substitute it in. So this will give me 1.2 times 1 cubed minus 4.7 times 1 plus 9.62. Now, we got decimals and we got a cube stuff, and we don't have a calculator in front of us. Is it really that big of a deal right now? Absolutely not. Because 1 cubed is 1. So this is just 1.2 minus 4. Oh, that 1, that's 4.7. Would help. It does help if you use the correct numbers, though. I don't know what I said, but I wrote 4.1. It is 4.7. So I don't know what actually came out of my mouth. Plus 9.62. And if we just do this a piece at a time, it's no big deal. If I combine those, that'll give me a negative 3.5 plus 9.62. So that means that h of 6 is equal to 6.12. Okay. If you have to actually do like major calculations with decimals and stuff, it would totally be on a calculator section. Nobody's trying to trip you up with that kind of stuff. All right, questions? Anything? Great, grab the next sheet of paper. This is also going on page 56 when we're done. Okay. Oh, and I overlooked, actually, I did this last period too. I overlooked part of the instructions that we're going to come back over here and talk about in a minute. But this says, blah, 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 find the value of h of 6 as a decimal approximation or indicate that it is not defined. So we will talk about what does it look like if it's not defined, okay, and why it says stuff like that. Because here we've got, all right, so we have the graph of function f, so we've got graph of f, a table for selected values of g, an equation of the piecewise function h, and a verbal description of k. And then we're going to use all this information to evaluate the following if possible. Okay, so we will look at some like what does that even mean if possible. So first, let's take our verbal description and make a little equation out of it. So k of x is a quadratic function. So our basic quadratic we know is just y equals x squared, with a horizontal translation of 2 followed by a vertical translation of -3. So then k of x would be equal to, it's going to be x, something going on there with the horizontal translation, squared. So what goes inside there with the x? -2 or +2. Which one is it? Minus, because this is a +2 and x is a liar, right? So -2. And then what goes at the end? -3, because y doesn't lie, right? So just go ahead and get it in your little equation there. Okay, so here we will start with f of g of 7. I've got to start by finding g of 7. Where am I getting that information? From the table, yeah. So what is g of 7? 4. Okay, so now I need f of 4. What is f of 4? -1. Therefore, f of g of 7 is -1. Any questions about where anything's coming from? All right. Now I have g of f of 7. I'm going to rewrite it like that. G of f of 7. So there's no question about what we're doing first. Okay. We need f of 7 first. Where do I look for that? The graph. And f of 7 is 2. Then that means I need g of 2. G of 2 is 3, right? When x is 2, g is 3. Therefore, g of f of 7 equals 3. So notice how I'm labeling my answers. I don't just have a random 3 out there. It asks me for g of f of 7, and so I'm stating what that is, what the answer is. Okay? We all good? All right. So now I'm going to rewrite this as h of k of 0. So I need to start with k of 0. K of 0, I got to put it in here. So this is going to be 0 minus 2 squared minus 3. What's that going to give me? 1. Good, because that is just 4 minus 3, and that is 1. So then I need h of 1. Right? Well, that's the piecewise function. Do I substitute it into all 3 of these? No, I look at the domain. That's the whole reason all this is there. This x is equal to 1. So when x is equal to 1, what is h? -4. Don't even have to do anything. So then h of k of 0 is equal to negative 4. Okay. Any questions at all? All right, so I'm going to scroll so I can write. So you're going to have to look at your own chart and stuff if you've been looking up here. So now I need f of 8. So I'm going to start with f of 8. What is f of 8? 0. Then I do f of 0. And what is that? Negative 3. Good. So then f of 8 is negative 3. We good? Any questions about where you think's coming from? All right. So here I'm going to rewrite this as g of h of 1. What is h of 1? Negative 4. Then g of negative 4 is pi. So g of h of 1 is pi. We still good? Okay. So I'm just going to keep rocking along because I think this is just, since this is just a review. So g of k of negative 1. All right, so k of negative 1, got to substitute that in. It's going to be negative 1 minus 2 squared minus 3. So what does that give you? 6. Good. That is 9 minus 3, which is 6. So then g of 6 is what? Negative 2. Good. So g of k of negative 1 is negative 2. All right. Any questions at all about that? Okay, so none of those came up as not defined. So we're going to go back up here and talk about a couple of things. If I'd have said, I want you to find f of g of 5. What would we have to find first? G of 5. What is G of 5? Not there. We don't know what it is. Does it exist? Maybe. We don't even know that because it just says selected values of G. If G is continuous, then yes, it exists, but it didn't even say that. So I'm not going to say that it doesn't exist because it very well may exist. I can't figure it out, though, from what they have defined for me. So that's when this answer would just be not defined or not possible. It depends on kind of how it's asked. Either one of them. I can't even spell. Not defined or not possible. Not that it doesn't exist, because again, it very well may. We just don't know. Then the other thing I want to ask you about is with this piecewise, what if I wanted h of 4? What is h of 4? Which equation do I use? First, second, or third? The third, because my x value is greater than 1, so I'm using this. So I substitute 4 into this, and I get negative 4. What if I want h of 0? Which one do I use? The first one. So that'd be the absolute value of negative 7 plus 3 times 0, which would be just the absolute value of negative 7, which is 7. So you have to be able to read these piecewise functions and understand what to do with them. Okay. Any questions at all about where anything came from? Okay. So then the last two are what some of the multiple choice questions might look like for on the exam. And on that first one there, you have to be able to read a table that doesn't just have 2 rows, but has 3 rows. It has 1 row of inputs, 2 rows of outputs, okay? It's not, sometimes this blows people's minds, but it's really not that complicated. So I'm just telling you that, don't make it harder than it is. So the table gives values of functions f and g at selected values of x. Functions f and g are defined for all real numbers, okay? So that tells me that this is continuous. So even though I couldn't tell you what f of 3 is, it exists out there. Well, I'm sorry, maybe it doesn't, but well, not all real numbers, yeah, it does. But like even f of 1.5, that exists somewhere, I just can't tell you what it is. And then let h be this function. What is the value of h of 1? One of the biggest mistakes some of y'all make on multiple choice questions is not writing stuff down because you know nobody's checking your work, and you stare at it, you do it in your head, you come up with any answer, but you fell right into their trap because it may not be difficult, but that's where you make your ridiculous mistakes, right? So write stuff down. So if I want h of 1, that's going to be f of g of 1. So what is g of 1? 0, because when my input is 1, the g output is 0. So that means I now want f of 0. And what is f of 0? Negative 1. When x is 0, f is negative 1. That makes your answer B. Y'all good? Okay. Any questions about where anything's coming from? Okay, good deal. All right, so then example 8. F, we got an f function defined, we got g defined, and we want f of g of x. So this goes into this one. So f of g of x is equal to, and then that's 3x plus 5 squared minus 3 times 3x plus 5 plus 7. So go ahead and work that out. Find your answer while I hand out your assignment, and then we will talk about that one. So write it out. Oh, good job. Yes, you can come grab a pass. It's laying right there. You can just grab it and go. Okay, this first little binomial, will it become 9x squared plus 25? No. Yeah. Mm-hmm. Good answer. What goes in between the 9x squared and the 25? 30x. Good. Hopefully none of you even remotely came close to D. I'd be really concerned if we got D. I'm a little surprised that one of the answer choices isn't if you made that 9x squared plus 25 mistake. I would totally put it on there because I know some of y'all would pick it. But maybe when that happens, that's kind of, a saving grace, and you can go back and figure out what you did wrong if it doesn't work out for you. Okay. Any questions at all? We good? All right. We got less than 3 weeks left. So let's finish strong. You got 10 minutes left. Get to work on stuff. Don't procrastinate. Take care of your business. Okay.